Okay, this video is on differential equations and we're solving them by separation of variables. So we've actually talked about this prior in the year, but we're going to go over it again. So remember, there's a whole course called differential equations that talks about all the different ways, or a lot of the different ways you can solve equations that have a derivative in them, which is a differential equation. But the only one, luckily, that we do in this calculus class is separation of variables. And so every single time, basically, you're going to separate them by putting together everything with the y, for example, on one side and everything with x on the other. The variables might just not be just x and y, but to solve them, you're going to put the terms that have y in them with the dy and the terms with the x with the dx, and then you can integrate it. And so your goal is to get something that says y equals. That's what we're trying to do, because we have dy dx to begin with, so we want an equation that says y. So let's go with the first example. So we want to find a general solution for all of the following. So if you remember, a general solution is going to have c in it. And then we will also learn how to do, or remind how to do, the specific solutions. So for this example 1, we're going to split this so that we have the y's on one side and x's on the other. So that means we're going to multiply both sides by y, so we get y dy, and then we're going to also multiply both sides by dx. So we get 2x dx. Then what we're going to do is we're trying to get what y is, and we have the derivative of it, so we're going to integrate both sides. Because of whatever we do to one side, of course, we'll have to do to the other. So when you integrate y, you get y squared over 2, and that's going to equal the integral of 2x, which is x squared, and then plus c. And if you remember, we're just going to put the plus c on one side, because plus a constant on one side and a constant on the other, you put them together, still a constant, so we don't need it on both sides. Now we're trying to solve for y, so multiply everybody by 2. And then keep in mind that I could multiply the constant by 2, but 2 times a constant is still a constant. Technically, those are different constants, so we could put C1 and C2, but a constant's a constant. You know, we solve for that at whatever point later. So I now have y squared, but I don't want y squared. I want y, which means I square root both sides. So we're going to always remember that means we have plus or minus the square root, so we have that answer. So that's the answer for example 1. So let's go to example 2. So here we need to split it again. So we want the y squared to be on the left and the dx to be on the right. So the dx is going to end up just being there alone, and then the y squared is going to come over here, but it has to be down on the bottom because we have to divide by y squared to get it alone. Then once we have them separated, then we're going to integrate both sides. And so if you don't remember how to integrate dy over y squared, you can always go over to a scratch area. And remember, we want to write things as powers very often. And so when we integrate it, we add 1 and divide by that power plus c. So I can come back over here and realize that's just going to be negative 1 over y. And then when I integrate just plain old dx, I get x. And then, of course, don't forget to put your plus c. Now, here's the part where we're going to solve for y, and y is in the bottom. So we want to get rid of that, but we also, so we're basically going to switch these around. So this y is going to go to the top over there, and this whole thing is going to go to the bottom over here. You can think of it like I multiply by y, and then I divide by x plus c. So we just kind of switch places with those two. So we get negative 1 over x plus c is going to equal y, and that's what I wanted, is an expression that equals y. I don't have to have y on the left, but if you like to write it that way, you can change it. All right, so let's go to the next one. So here we have a product on the right, and we still want to split it. So we have dy, we want to stay on the left. So we're going to divide by y to move it over to the left-hand side. And then to get the dx over, we're going to multiply by dx. So we moved y down, dx up. And now we want to integrate both sides. So we integrate the two sides, and if we integrate dy over y, you need to remember that's like du over u, so we get ln of the absolute value of y, and then if we integrate x, we get x squared over 2, and then of course plus c. Well, I don't care what ln of y is, I want to know what y equals. So here is where we're going to change this to an exponential equation. So the equivalent exponential to this would be, you have ln of y, and remember that's e on the bottom. So you're going to have e to the x squared over 2 plus c is going to equal absolute value of y. So it's e, it's the base that's down here that we really don't have it written. Remember, ln just means log base e, so it's e to the answer over here equals the inside. Now, let's talk about several things here. I don't need to keep the absolute value sign because if I look at this problem, let's think about it. It's e to the something on the right. Well, e to the something is always positive, so I don't need absolute value, so we can drop that. So we have y equals e to the x squared over 2 plus c. And we can also do some changing here that's kind of important because this is going to come up in a couple of sections that we're going to do quite often, and that's solving with an exponential. So we're going to notice something that I'm still solving for y, but I want to simplify it a little bit more. If you remember your properties of exponents, if you are multiplying something that has the same base and has exponents, then we add the exponents. Which means if I'm adding exponents, I could go backwards and make it something multiplied with the same base that has exponents. So I basically just sort of undid the property. If I have x squared times x cubed, I get x times 2 plus 3. Well, I just did it in this order. If I have addition, then I can write it as a product. So that's all I did. Well, e to the c, e is a constant, c is a constant, so that's just another big constant. And so we actually normally write this capital C e to the whatever, in this case x squared over 2, and that's what y is. So this one's actually going to come up quite a bit, something in that same format here in a couple sections. So that's a good example of that. All right. And keep in mind, if you ever at any time need to stop and slow down the video or rewind or go back and watch it, just please do that. All right, so this one is written with a y prime in there, so be careful. You might want to rewrite it dy dx so that you can see what's going on here. So I want to split things. Well, this time I've got some addition that I need to kind of get rid of. So I really want to leave 4y dy dx on the left and move the negative 3 e to the x to the right. So I'm going to add 3e to the x. So now I've got y on the left and x on the right, and I just need to move my dy dx. So the left is 4y dy, and the right is 3e to the x dx. And now I'm going to do the same process. I'm going to integrate both sides. So when you integrate 4y dy, you're going to get 2y squared. And when you integrate 3e to the x, remember e to the x is a super easy one. You just rewrite it. So I get 3e to the x plus c. And now I'm going to divide by 2. So I get y squared equals 3/2 e to the x plus c divided by 2, but a constant divided by a constant is still a constant. So we can just still put c there. And then I'm going to square root, and we're going to remember plus or minus 3/2 e to the x plus c. And so there will be our answer for this problem. So we have two things that y equals, plus or minus. All right, so let's go to number 5. So we want to still find the general solution to this. So again, I'm going to split things. So it's going to be 3y squared dy equals x squared plus 1 dx. Be sure you're using parentheses there because it's the whole x squared plus 1 on the right. Now again, integrate both sides. And so when I integrate 3y squared, I'm going to get y cubed equals, and I integrate over here, I get x cubed over 3 plus x plus your constant. And I want to know what y is, not what y cube is, so I cube root both sides. There's no plus or minus when you do cube roots. That's for even roots or square roots, and I don't have that. I have a cube root, and there's my answer. So my c is just inside there, and that's okay. All right, so the next examples are going to be particular solutions. So we're not going to just get the general solution. After we get the general solution, then we're going to find that constant, so we don't have that. Now this time we have dx dt instead of dy dx. It doesn't matter what the variables are, the idea is still the same. So here I would be solving for x. And you can also kind of see that right here because you see x of 0. So think of like a position equation. You know, often they use x instead of s. So you can think of it that way. So that means this part is t and this part is x. Okay, so that'll be important. So let's go ahead and separate this. So I'm going to leave on the left the x part because the dx is there in the top. And I'm going to move e to the minus t to the right. Well, remember that e to the minus t just means 1 over e to the t. So if I move it to this side, it's e to the positive t. And it's times a 1, so that doesn't change anything. And then let's go ahead and move the dt also. So if you need to, you can pause it, look at that, think about it for a minute, and then move on. All right, so we're going to integrate both sides. So we integrate on the left, and we have x squared over 2 equals on the right. Remember, e is just to rewrite it, so I get e to the t, and then of course I have plus c. And then at this point, so we can solve for c at any time. I normally solve for c now. So I usually don't wait and do that. So I'm going to do it over to the right, kind of in the scratch area. I could solve it in next or whatever. I'm just going to do it over to the right. So I have x squared over 2. So instead of x, I'm going to put 1. So that's 1 squared over 2 equals e to the t, but t is 0. Remember, looking up here. And then plus c. And so this is going to give me 1/2 equals, remember, e to the 0, anything to the 0 is 1, except 0 to the 0. And then we still have plus c. So therefore c is negative 1/2. So my actual answer to the whole problem is, so this was kind of step 1. This is the general solution. And then this is find the constant, so that's kind of step 2. And then step 3 is to go ahead and write the actual particular solution. And the particular solution is just to substitute that in, and then we may have to do some more solving. So instead of c, I write negative 1/2. And now I don't care what x squared over 2 is. I want to know what x equals in this case. So I'm going to multiply everything by 2. This time I do have to multiply 2 times negative 1/2 because it's no longer a generic constant. It's an actual number. So that's going to end up being minus 1, and then x would be plus or minus the square root of 2e to the t minus 1. And that would be your particular solution. All right, so example 7, same thing. So first thing we do is find general solution. Plug in your initial conditions. I generally do it right after the first time I do an integral, and unless there's just some basic arithmetic-y kind of simplifying, I'll do that first. And then after I've done that, I substitute it back in and then continue solving. So we're going to separate again. So we have to leave everything with a x in it needs to stay over here to the right. So that's 1 plus x over x dx. Then we're going to multiply by y to get this y out of the bottom. So that gives me y dy. And then we're going to integrate both sides. So we get y squared over 2 equals, well, to integrate the right, we're going to need to use some of those things that we learned. So if you have addition or subtraction, remember basically the same thing. So we're adding over a single, over a monomial, we can split it. So we're going to make this 1 over x dx plus the integral of, well, x over x, which would be 1 dx. And that's one of those techniques that we did for simplifying integrals. So we still have just y squared over 2. 1 over x integrates to being ln of absolute value of x plus the integral of 1, which becomes x. And then remember, we got to have a plus c once we start integrating things. And so we want to go ahead and continue. And now we want to go ahead and find y. So they told us that y of 1 is -4. So let's go ahead and do that over here to the side. So y of 1 is -4. So that means y of 1 means this is x and this is y. So instead of y, I'm going to put -4 squared over 2 equals ln of absolute value of 1 plus 1 plus c. So -4 squared is 16 over 2 is 8. ln of 1 is 0 plus 1 plus c, therefore c equals 7. So now we're going to go back over. So step 1, get general solution. Then go over here and find c. Then come back over and fill in c. So that's ln of absolute value of x plus 7. Now multiply everything by 2. So y squared equals 2 ln of absolute value of x plus 2x plus 14. And then we want to square root, and we get plus or minus the square root of that whole big thing that we had written. But we're going to realize that we don't need plus or minus. That wouldn't be a very good particular solution because that's more than one solution. So let's go back up and realize that our initial condition said y of 1 is -4. So that means the particular solution we want is not the positive one, but the negative one. So the actual answer to our problem is the negative of the square root, because remember, it's both. And in this case, I only need that one. Okay, so we have a couple, or one more example, and then you can take your turn to practice. So we need to split this up. So first thing we need to do is it's square root of y dy dx equals a minus square root of x. So you want to get that split so that you have two sides. And then we need to get our x's together and keep our y's together. So square root of y dy equals minus square root of x dx. So again, we're going to integrate both sides. And when you integrate the square root of y, if you need to, you can kind of do that over to the side again. This would be the same thing as y to the 1/2 dy. So therefore, when you integrate it, you're going to get y to the 3/2 divided by 3/2, but remember, we just go ahead and write times 2/3 equals negative, and then you'll have 2/3 x to the 3/2 plus c, because you get basically the same antiderivative there. Then remember, go ahead and plug in now in order to get your c. So let's go over here to the side. Y of 1 is 4, so that means instead of y, we're going to put 4. And instead of x, we're going to put 1. And all of that is in order to find c. So on the left, we have 2/3 times. Remember, when we do our exponents, we do square root of 4, which is 2. 2 cubed is 8. And then 1 to the anything is 1. So this just becomes negative 2/3 plus c. So the left-hand side is 16/3. The right-hand side is negative 2/3. So that's going to become 18/3, which is 6. Okay, so now we found the constant, so now we're going to plug it back in and write down our particular solution and then solve for y if we need to. So we have 2/3 y to the 3/2 equals negative 2/3 x to the 3/2 plus 6. Now we want to get y by itself, so we're going to multiply everything by 3/2. So negative 2/3 times 3/2 would be -1. So we'll get negative x to the 3/2 plus 6 times 3/2, which would be, again, write stuff to the side, don't stare in the air. 6 times 3/2 would be 9. So we get 9 there. And then we can raise both sides to the 2/3. So that's going to be minus x to the 3/2 plus 9, whole thing to the 2/3. There would be other ways you could write that, and that would be one of them. And so there's our examples for separation of variables. Remember, you can certainly rewind the video and watch again. And just do whatever you need to make sure you understand. You can pause it if you need to catch up with something.